In this short video, we're going to describe a few simple instructional activities that are appropriate for use in conjunction with the patterning and partitioning activities that we've described in earlier videos. These activities are not part of the patterning and partitioning sequence per se, but they complement it and can be interspersed throughout. Our intention is that these activities will be used only sparingly. And as with all of the inquiry instructional activities, the intention is not that students learn to do these activities or get good at them. Rather, through engaging in these activities, students have opportunities to further their conceptual development of number, and hence their learning. Each of these activities provides a context for posing tasks. These 4 activities are hidden objects, single-decker bus, a double scenario, and a money scenario. We're going to describe each context and explain how it can be used productively to pose problems to the students. The first one is the one we call hidden objects. It uses a context of animals and a barn. So there's a picture of a barn and some sheep. The teacher shows the picture of the barn and the number of sheep that she wishes to use in the task that she was going to pose. Just cover up the remaining sheep so the number visible is the number you want the task to be about. It's not a flashing task. The picture remains visible throughout. We'll explain how to use the context by using the example where 3 sheep are visible. Here are some sample questions. There are 4 more sheep in the barn. How many sheep are there? Or, there are 6 sheep in all. How many are in the barn? The first sample question is an addition task. The second one is what we would call a missing add-in task. How might children approach these tasks? Well, as we've said before, the intention is that these tasks should be used alongside of the patterning and partitioning activities. They can be interspersed and used relatively early. So in that sense, many children will use finger patterns to figure these out. Notice the similarity of these tasks to finger pattern tasks. The first one is very similar to show 3 fingers, show 4 more, how many fingers do you have now? The second task is very similar to show 3 fingers, how many more do you need to have 6? Here are some more sample questions. There were 5 sheep in the barn and these came out. How many are still in the barn? Or, there were 7 sheep playing in the barnyard. Some went into the barn and these stayed in the yard. How many sheep went into the barn? These sample questions can be thought of as subtraction, though we don't use that language with the students. The first task is a simple takeaway task, 5 take away 3. What will children do? Well, many will use their finger patterns to solve this task, and others will already just know that 5 take away 3 leaves 2. This task is similar to the finger pattern task, hold up 5 fingers, take down 3. How many do you have now? The second task is more complicated. The general format of the question is a missing subtrahend question. If you start with 7, how many do you have to take away to have 3 left? This task is similar to the finger pattern task, hold up 7 fingers. How many do you have to take down to have 3 left? This similarity of these tasks to the finger pattern tasks provides some guidance to the teacher about when these might be used appropriately. What is the purpose of the hidden objects activity? It's to provide an opportunity for children to develop concepts related to simple addition and subtraction tasks and the more complicated missing add-in and missing subtrahend tasks, using a limited amount of perceptual material. What are the features of these tasks? Well, for one thing, the tasks are posed using meaningful stories and not using the formal mathematical symbols or language associated with written tasks. For example, the task might be there are 3 sheep that we can see in the barnyard. There are 2 more in the barn. How many sheep are there on the farm? Nowhere in the statement of the task is the language of addition or subtraction used. Second, the sample questions are at varying levels of difficulty. In any given lesson, the teacher may decide to limit the questions to 1 or 2 types, depending on her purpose for the lesson. As with all activities in this sequence, the purpose is to have children figure out tasks in ways that make sense to them. It's not to get them to use a specified approach. For example, many children at this stage will not count on to solve a missing add-and task because they have not yet developed number as a composite unit. Such children are unable to count on meaningfully. If we insist that they do so, they will try to learn, what is it that I'm supposed to do, rather than figuring out something that makes sense. We always have children in our classes at different levels of conceptual understanding of number. Consequently, children give solutions at different levels of sophistication. This rich variety is powerful because children don't attempt to use methods that are beyond what they can understand. Rather, they begin to take over methods that are just beyond what they've been doing. So in this way, they gradually advance in their level of sophistication on their own. That is, students differentiate the instruction themselves. Now, this issue is important because it points to the difference between a child coming to think of mathematics as something that makes sense and is comprehensible, or thinking of mathematics as a collection of incomprehensible rules and procedures, something that is confusing and anxiety-producing. What we're pointing to here is how it is that children develop mathematical self-confidence. The bus context provides another storyline for posing additive tasks to students. This context is taken from the work of Jan van den Brink of the Freudenthal Institute in the Netherlands. We've added the phrase single-decker for the teacher's benefit to distinguish it from the double-decker bus that was described in the partitioning activities. In this storyline, there's a bus that travels along and stops at various stops where people get on and off the bus. The activity is very flexible in that the teacher creates the story to suit the purposes of the lesson. For example, the story might be that there are 5 people on the bus. At the first bus stop, 2 more people get on. The class figures out how many people are on the bus now. It's 7. The bus stops again. This time, 1 person gets off the bus. The class figures out how many are on the bus now. It's 6. The teacher can continue the story in this fashion for as long as she wants. The teacher poses the story. The children figure out how many people are on the bus as she goes along. She can draw a picture and fill in the numbers just as we've shown in this example here. Numeric symbols indicate what happens at the stop. For example, +2 means that 2 people get on. -1 means that 1 gets off. In this way, the teacher introduces the symbols plus and minus very naturally without referring to them with the formal mathematical names of addition and subtraction. Plus just means more people get on, and minus simply means people get off. Well, there are several interesting variations of the bus activity. In this variation, an entire story is laid out in advance, and the children figure out the story. That is, they tell the story of what happened. This variation is designed to ensure that children understand the storyline and the symbolism used to show it. All of the numbers are filled in. There's nothing to figure out. The children's task is just to read the story, tell the story of what happened. The bus starts off with 6 people. At the first stop, 3 get on. Now there are 9 people on the bus. At the next stop, 1 gets off. Now there are 8 people on the bus, and so on. There are several other variations of the bus activity. In this variation, the teacher shows the students a bus story with some missing quantities, and the children's task is to figure out the missing quantities. Now, this could be done in a whole class setting, where this is shown on the whiteboard, or if the teacher wants the children to work individually or with a partner, she can have this on a piece of paper that they work on. But the simplest version of this activity is shown as in example 1. The number of people on the bus at the beginning is given, and what happens at each bus stop is given. And so the children's task is to figure out how many people are on the bus after each bus stop. But example 2 is a little more complicated and maybe more interesting. If you look at the beginning of it, for example, we know that there were 4 people on the bus at the beginning, and after it stopped at the first stop, there were 6 people on the bus. Now the children's task is to figure out what happened. Did people get on or off? How many? As it goes along, there's 6 people on the bus. At the next stop, 1 gets off. How many are on the bus now? They figure that number out. It'll be 7. And now again, they have to figure out what happened at the bus stop. So it continues on in this way. So the second one is more complex than the first. This would be interesting if it were used in individual or partner work to have a class discussion afterwards. And remember, the discussion isn't to see if the children got the right answers, but is to talk about how they reasoned to figure out the missing quantities. Here's a third variation of the bus activity. Have children create their own bus stories. Either tell it or use paper and pencil format to write it down. This is very open-ended. It's always interesting to see what children do when they create their own stories. Our experience shows that they reveal a lot of what they understand when they do this. They often use numbers that are comfortable for them. For example, the most sophisticated children will use larger numbers. The least sophisticated children will use smaller numbers like 1 or 2. Some people will have 1 person getting on at a bus stop, 1 person getting off at a bus stop. You can see that this activity is really very open-ended and will reveal a lot to the teacher. Just to recap, what are the purposes of the bus activity? Well, one purpose is to introduce the symbols plus and minus to signify more and take away. In our experience, many curricula introduce formal mathematical symbolism, such as number sentences, far too early before children have a chance to develop informal concepts. They talk about adding and subtracting. Here, we're just simply talking about more and taking away, informal concepts. Another purpose is to provide an opportunity for children to verbalize the meanings of plus as more and minus as take away, and to provide tasks that foster the concept of reversibility of operations. 3 people get on at 1 bus stop. The next bus stop, 3 get off. Oh, we get back to the same number. This bus activity is very versatile, and teachers will surely think of ways to use it that aren't included here. We encourage you to be creative and make it your own. It's easy to use it from time to time in conjunction with the patterning and partitioning activities. The double scenario provides another context for posing questions. For example, we might have a Ferris wheel. Each car of the Ferris wheel holds 2 people. How many people can ride in 4 cars of the Ferris wheel? Or a twin scenario. Mrs. Smith bought 6 markers for Tom and the same number for Tim. How many markers did she buy? The purpose of this activity is to foster children's development of doubles combinations. Children have a natural tendency to learn doubles early. When they have them in hand, they can use them to solve other related tasks. For example, a child might figure out that 6 and 7 make 13 because 6 and 6 make 12. Money provides another context, and we're suggesting using pennies and nickels as visual material to pose questions. For example, this is Sue's money. Now we can see it. Can she buy a sticker that costs 7 cents? Or another example. Who has more money, Sam or Sue? Here's Sam's money. Here's Sue's money. What are the purposes of using a money context? Well, one important purpose is to foster the development of a composite unit of 5. Using a nickel as 5 is actually an early use of coordinating units of different rank. The nickel is a single unit that it is itself made up of 5 smaller units, pennies. In actuality, the situation is even a bit more complicated because a nickel isn't made up of 5 pennies, but instead has the same value as 5 pennies. It's one thing that has the same value as 5 things of lesser value. Coordinating units of 2 rank is very complex, and it can be quite difficult for some children. Early work with nickels and pennies provides many opportunities for children to encounter and work on these difficult conceptual aspects of number. What are the overall purposes of these additional activities? These activities use story context to pose tasks, and in that sense can be thought of as general problem solving. Discussions are integral to these tasks. Having said that, teachers have to remember each lesson has to keep moving along and not drag on. So teachers have to make judicious decisions about when are they going to call for more than one solution or have more than one child explain, how much to explain, and when to simply just move on to another task. We remind teachers that our intention is not that children learn to do these activities. Rather, they are a means through which children learn. In other words, our intention is not that an activity is used over and over until children can easily do it and get it correct right away. These activities are designed to promote conceptual development of early number concepts. We include a timeline here for your reference. Here we see the patterning activities, the partitioning activities, and the additional activities for small numbers. And the dotted lines on each, after each instructional activity indicate when it can be used productively within this whole set of activities. The next videos will be for the structuring numbers sequence.